What if you could update a digital notice board wirelessly, using just your phone and even trigger alerts with a buzzer, all powered by a tiny ESP32? In this project, we are building a wireless notice board that displays your message on an OLED screen and beeps a buzzer to grab attention, all updated from a sleek web page hosted on the ESP32 itself. To bring this smart notice board to life, you will need one ESP32 dev board, one SSD 1306 128x64 OLED display I2C module, one active buzzer, one breadboard, jumper wires, one micro USB cable. Now let's build the circuit. First, take your breadboard and your ESP32 development board. Now we'll power the breadboard. Connect the 3.3 volt pin from the ESP32 to the positive power rail on the breadboard. Then connect the GND pin from the ESP32 to the ground rail on the breadboard. Next, let's connect the OLED display. Insert the OLED module properly into the breadboard. Make sure the pins are not bent and everything is lined up correctly. Now connect the OLED pins, GND to the ground rail, VDD to the positive power rail, SCK to GPIO22 on the ESP32, that's your clock line, SDA to GPIO21, that's your data line. Now it's time to connect the buzzer. Insert the buzzer into the breadboard. Connect the negative pin of the buzzer to the ground rail and connect positive pin of the buzzer to GPIO23 on the ESP32. Double check your connection according to the circuit diagram before firing up. Now download the code and library files given in the description below. Open the code and library files if you have already downloaded the Arduino IDE. Otherwise, download the Arduino IDE first. This library helps us connect to Wi-Fi, communicate with the OLED display using I2C module, and connect render graphics on the screen. Replace your Wi-Fi SSID and your Wi-Fi password with your own Wi-Fi network credentials. This sets up the OLED screen dimensions and declare the display object. This starts a web server on port 80 and sets the buzzer pin to GPIO23. Begin serial communication and set the buzzer pin as output. Start I2C communication and check if OLED display initializes correctly. Show a temporary message on the screen while Wi-Fi connects. Connect to your Wi-Fi network and print the local IP address for access. Wait for a client to connect to the web server. Read the full HTTP GET request from the user. Find and extract the text typed into the waveform and clean up any URL encoding. Beep the buzzer 3 times to notify that a new message was received. Clear the old message and print the new message on the OLED display. Respond to the browser with an HTML page. This part sends a fully styled web page that allows the user to type and submit a message to be displayed. And that's it. Now we will upload the code to the ESP32. Plug your ESP32 into the computer using the USB cable. Select the correct board ESP32 dev module. Then go to the tools and select the port where ESP32 is connected, as for example COM4. Make sure to replace the Wi-Fi name and password here. Now click the upload button, the right facing arrow. If you see connecting and dots appear, just hold down the boot button until it starts uploading. Once uploaded, open the serial monitor and set the baud rate to 115 to 00. You will see message like connecting to Wi-Fi ... And then Wi-Fi connected and IP address will be displayed. Note down the IP address. Open your device browser and type the IP address in the address bar in any web browser on the same Wi-Fi network. This IP is your gateway to access the live weather dashboard. When you will open this IP in your browser, you will see a beautiful web page where you can type a message and hit send. The OLED will instantly update the message and then the buzzer will beep 3 times to alert nearby users. Customize your project. Add different fonts or emojis to the OLED screen. Include date and time or scrolling text. Use a larger display like TFT or LED matrix for bigger messages. Add a mobile app interface with Blink or MIT App Inventor. If you like this project, don't forget to like, share and subscribe for more exciting DIY tech with Roboarmy.